Once again, we would like to thank our sponsors. And the first presentation is coming from Kaining Ding. He is head of silicon heterojunction solar cell and module development at Forschungszentrum Jülich. He is going to give a keynote on what's hot in heterojunction technology. And Kaining has also been very key in making the Silicon Heterojunction Conference, which is held annually. Kaining, the floor
Hi,
is
Sean.
yours.
Yeah, can you hear me?
Yes.
Yeah, so thank you very much for the kind introduction and for the invitation. So always happy to be here at the Taiwan News Conference. So as promised, I wanted to give you a general feeling about what is going on in heterojunction in 2024. So that there's a good fundament for the other speakers to talk to diving into the topic. So maybe just very shortly a few slides about where I'm coming from. So I come from Forschungszentrum Jülich, which is part of the Helmholtz Association. And the research center Jülich is actually a quite big center. It hosts more than 7,000 employees working on energy, bioeconomy, and information technology. And inside this center, there is an institute called IMD3 Photovoltaics. That is an institute for PV. And in this at this institute, we have a department called Silicon Heterojunction Cells and Module Department. We are like 30-ish people working on heterojunction cells and modules. So we are operating a complete cell and module line for cells up to G12 half cut. Using industrial scalable equipment and also a high number of characterization tools. And also, in addition, we have a perovskite top cell line, allowing us to make perovskite silicon heterojunction tandem cells. But the size here is in the moment limited to 2 by 2 or 1 by 1. But everything is available to produce the bottom cell and the top cells, or everything in house, and go until the module level. So talking about heterojunction, so I would like to start with a status quo from the industry. In the moment, the usual formats for the cell is G12 half cut or G12R or G10. So G12R is a format which has half of a 210. So like it's somewhere a format between the G12 and G10. I think it's maybe a consolidated version of a wafer format. And in the moment, the wafer thickness is in the industry still 110 micrometer, with some of the manufacturers utilizing 90 micrometer. And the super multi-boost bar design is still the state of the art with like 20 boost bars. But there's also already some companies starting with 0 BB. So I will also talk a little bit about that. So the microcrystalline silicon oxide is standardly used on the front, and microcrystalline silicon P layer on the back. And the screen printing has shifted to stencil printing using a nickel or steel mask. This has some real good. I mean, this seems to be one of the major successes of the cost reduction in the moment, that can reduce the consumption of metal significantly using this technology. In the moment, the copper silver paste contains like 40 to 50% silver, and there's some trend now going towards 30% silver in the mass production. So usually the silver content on the front side is usually still a little bit higher than on the back. The mass production efficiency, just to be very honest, is somewhere 25.4% and 25.5%. So these are the average efficiencies that you could certify at these certification labs. But the production, the measured efficiency is somewhat a little bit higher. So in the moment, it's already 26 to 26.2%. And on the module side, the module design has, in my opinion, consolidated a little bit more. So it's more common to use a bifacial glass module. And PIB-based edge sealant is a must. So all these two things are important to protect the module from moistures. And the glass, front side glass is textured and coated, and the rear glass has these reflective stripes between the cells to increase reflection into the module, into the solar cells. And also the UV downshifting encapsulant. So I prefer to call it UV downshifting, but it's also known under the term down conversion. So the downshifting encapsulant, there has been some reports on instabilities, but this product has evolved during the last year. So I think the majority of the product now involve UV downshifting encapsulant, and they are quite stable. So the commercial module now is above 23%, but of course with the record efficiencies much more above 24%. But commercially, it's in the moment maybe 23% module efficiency. And here I have some ongoing selection of some ongoing topics that are being introduced into the industry. So maybe not 100% there yet, or on the way of being introduced into the industry. So one thing is about the continuous CZ approach. On the left, you can see how the rechargeable CZ is working. So basically, you are depleting the liquid silicon, and then after that, you replenish the whole thing with new charge of polysilicon. And this will take some time because every time you have to remelt the polysilicon. And there is certain advantage of this continuous CZ where you are continuously fitting while you are pulling out the ingots. You are fitting in some polysilicon. And the drawback of this technology is usually a little bit higher content of oxygen, but that does not harm too much the heterojunction because the heterojunction technology does not undergo any high temperature processes during the production. So the heterojunction is able to make good use of this CCZ approach. And especially this CCZ approach goes very well with fluid bed reactor produced this granulate of silicon, which is cheaper, but maybe from the purity level a little bit lower. But as I said, the heterojunction wafers does not require the same quality as the TOPCon due to the low temperature processing. So all in all, if you combine this continuous CZ and FBR granulate, this is a very strong tendency towards the cost reduction on the wafer size, in combination with the thinner wafer trend. So I think there is a lot of potential for have lower cost for heterojunction in terms of silicon cost. And also an important topic in the moment, maybe not the perfect example, is the dark degradation. So usually the solar cell in the production undergoes a light soaking process to improve its efficiency. But if you put these cells in the dark, they tend to decrease a little bit in efficiency again. And what is maybe wrong in this example with the rose is that in the degraded states, if you do a light soaking, you will again be able to recover it. So the dark degradation is an issue because the time between after finishing the cell and making the module, there is some time in between, and the module will start with the cell that has lower efficiency. And also you could think about making light soaking at the module site, but this comes again with additional cost. So not preferable solution. So ideally people want to solve this dark degradation issue. And so far the observations have been that if you put it in the nitrogen box, the dark degradation seems to be lower. So this indicates that this dark degradation is somehow related to the environment, like moisture. And also there has been some observations that the increase in the oxygen content. So if you move from amorphous silicon to nanocrystalline silicon oxide, the dark degradation seems to be stronger. But most recently, there has been some reports about using N2O as a oxygen source for the nanocrystalline silicon growth instead of CO2, and the dark degradation issue seems to be controlled by changing this step. This indicates somehow that the dark degradation might also be related to the carbon that is being introduced a little bit in a small fraction into the material while growing the nanocrystalline silicon oxide. Yeah, so it's not really understood yet what is going on there with the dark degradation. It is an industrial issue. We are not talking about strong degradation. I mean, it's a relatively small degradation, but it will cost you a few watts if you are making the module. Yeah, so in the moment, it seems like there's a workaround, at least if you try to use N2O instead of a CO2 to do your nanocrystalline silicon oxide, but the mechanisms is still unknown. And also on the module level, as I mentioned, there is a shift, there is urgency, let's say, towards the shifting to 0BB to further reduce the consumption cost of metallization, and also to increase the efficiency on module level. There are different concepts out there being tested, and they differ a little bit in the way how the positioning of the wire is managed and how the contacting is happening. Here I just put out one example, which is seems like to be the most favorable solution in the moment, is to either use a smart wire technology by Meyer Burger, so where the positioning of the wire is done by embedding the wires on a polymer foil before you're making the module. And the wire is coated with some low temperature melting point, so alloys, solder alloys that have low melting point. So the contacting happens during the lamination. So where the temperature during the lamination will melt the solder alloy and connect the wire together with the fingers. And in the case of XN Automation and Maxwell, they are doing it slightly different. So the wire positioning and adhesive foils are not prepared beforehand, but they are adjusted and laid down on the cell in the integrated equipment. So the wire and adhesives are laid down on the cell in the same equipment. They call it the IFC approach. But the contacting is the same idea. So the contacting happens during the lamination, where the surface coating, alloy coating, is melted and that does a connection between finger and the wires. Yeah, this seems in the moment to be the most favored solution, because as soon as the soldering, active soldering, is involved before you make the lamination, there are some eventual issues with temperature coefficient that can create stress in the wire and breaking the wires or breaking the cells even. Here is a status quo about the efficiency. On the right, you can directly see. So heterojunction M6 is 26.81%, and HBC M6 27.3%, and the highest heterojunction module efficiency is 24.99 by Tongwei Solar. And the perovskite heterojunction small size held by Longji 34.6. M6 cell 30.1, and on the module level, the perovskite heterojunction module is 26.9%. So just as a most recent data on efficiencies. And actually, you will be able to track a lot what is going on in heterojunction by reading the Taiyang News press releases. I just picked out two, which hints a little bit towards a trend. One is there is a club for high efficiency heterojunction solar modules. They call it the 740 watt plus club. This basically involves in the moment all the major heterojunction manufacturers in China. This is in the moment I see as a little advantage of the heterojunction community, which is much smaller than that of TOPCon. Which helps them to come a little bit more closer to discuss about the common goals and common ways how to manage this business well. So I think because they are in the minority as compared to TOPCon, it brings the people a little bit closer. This is at least a feeling I have. And another thing is as you can see on the right, there was some memorandum of understanding between the Italian company and the Hwasong. This is I do not want to focus too much on this particular case, but there is some trend about Chinese heterojunction manufacturers being willing to become a service provider, of a solution provider for heterojunction outside of China. And this is I think it can be in different countries, but I think it's maybe one interesting scenario in the coming years. And in China itself, the situation is quite critical, as all of you know. But as I see it in many of the tenders, auctions, there is some heterojunction specific calls. The volume is not very large as compared to TOPCon, but I have seen the prices at which the auctions are happening. It is a little bit in the case of heterojunction is a little bit above the production cost. So I think you can in the moment, if you are a top tier producer of heterojunction, you are still making some sort of a profitable business. Yeah. In the case of TOPCon, eventually the lowest bids are maybe already below the production cost. Simply because of the much stronger competition there, I think. But outside of China, there are some encouraging news, let's say, about HAT consortia in India and USA, Middle East, and Turkey. And a little bit in Europe, but partially in Europe. So I mean, Italy has some policy in place to support the PV manufacturing, but not so much else I can see. But like India, USA have the strong political support for PV production, and Middle East and Turkey as a turning point of the world are just very attractive in the moment for setting up new product capacities. And there's a new international. I will come to the end. Yes, yeah. Okay. There's a new international heterojunction platform initiated in 2023. Yeah, so last year the meeting was taking place in China, and this year it was in Italy. And if you are working on heterojunction and as an entity and you want to join, yeah, it is actually free of charge. This alliance is meant to bring the community worldwide together to help each other advancing. And as Chauvin mentioned, there was an international heterojunction workshop happening this year in November in Catania. And just two examples on the system aspects. Because I'm running out of time. I just want to conclude one thing. Is in the moment with the cost coming down, because the production cost has come down quite a lot for heterojunction without many people noticing it, because the TOPCon has advanced much quicker. But the cost has come down a lot, and with all the beneficial aspects on the system level for heterojunction, actually heterojunction is a meaningful case on end customer situation. So actually, it's not like there is going to be absolutely a domination of a technology, but I think heterojunction is becoming a really interesting case on the system level. And also HJT, which is afraid of moisture. People now have demonstrated also you can make it using floating PV. So the moisture problem and the UV degradation problem, so people can target. It's just it's actually something that has been ongoing for a while. Yeah. So I just yeah, that's actually it. Yeah. And I would like to thank you for your attention. Yeah, sorry for a little bit overtime.
That's fine. Thanks, Kaining. I do have questions, but probably I would like to include them in the panel. Anyway, we are talking again. So then I would like to move on to the next presentation. But meanwhile, if there are any questions in the panel, it would be great if you can answer them. Sorry, in the chat, please answer them in the chat.